Hi, welcome to today's lesson. Our learning target today is I can measure distance on a coordinate grid. So let's look at applying a coordinate grid to something from the real world. Did you know that a GPS, global positioning system, really uses something like a giant coordinate grid that covers the entire planet in order to tell you exactly where you are in order for things like Google Maps to work. It's kind of cool. All right, so here we have nothing nearly that complicated. We have a first quadrant coordinate grid, and on it we see trees and letters, and we also see a key up here in the top left corner. And a tree is a tree. Interestingly, the star in the circle is a house, and then we're told that each square on this coordinate grid is equal to 1 square yard. Now, that's important. That means, because it's a square, that every side, like this side here, is 1 yard long. That side's 1 yard long. That's going to be really important when we start to measure distances on this coordinate grid. We also see over here on the right questions. Now, this kind of work is exactly what you'll do today for practice, okay? So this is going to serve as a model, not just a learning experience for what you're going to do independently. Let's get to our first question. Number 1, which tree is closest to the house? Well, we can see from our key that the house is actually the star. And we can kind of just sort of intuitively see that B is closest. Let's pretend, though, that we're not quite sure. Maybe D is closest. We don't know. Here's how you measure. The key tells us that one side of a square is a yard. So starting at the house, which is also the origin, it's the 0 on both number lines, we can count each side of a square all the way to the point that we're looking for, in this case, tree B. So we could count 1, 2, 3, 4 yards from the house to the tree letter B. But what if I want to count a different way? What if I want to count 1, 2, 3, 4 yards again, even though I took a different route? That's interesting. What if I went this way? 1, 2, 3, 4. Huh. That's interesting. It must be that B is 4 yards away. Well, let's look at tree D. Let's count 1, 2, 3, 4, 5 yards away. So, in fact, B is the closest tree to the house. So we'll say B as our answer. Now, the next question says, which tree is furthest from the house? Well, again, intuitively, we'd say A looks furthest, but maybe it's E. We should check. Let's count both. So starting again at the house, let's say we want to count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 yards from the house to tree A. And it's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 yards from the house to tree E. But wait, maybe you're thinking to yourself, but if you take a different route, maybe it's different. Maybe we should measure again. All right, well, let's take a different route to A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 again. Isn't that weird? It's 15 no matter which way I take. Let's try tree E one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. Huh. I think I see a pattern developing. Do you? Yes, it turns out that as long as you are always heading in the general direction towards a point on a coordinate grid, you are going to come up with the same distance. So back to question 2 real quick. The tree that's furthest from the house is tree A. But back to my point even quicker, let's take a look at tree B one more time. Let's go back to the start here. No matter which way we took, 1, 2, 3, 4 yards going that route, 1, 2, 3, 4 yards going that route, it doesn't matter. What if we went through the middle? 1, 2, 3, 4. As long as you're not backtracking or intentionally moving away from your target, no matter which route you take, you're going to end up with the same distance between the starting point and the ending point. Isn't that interesting? Let's look at question 3. If you were to go 3 yards east and 6 yards north from the house, which tree would you end up at? Well, here's something. I've included a compass rose here. Compass rose shows the 4 cardinal directions, right? We have north, which generally on a coordinate grid is up. We have east, which is generally to the right. We have west, which is generally to the left, and south, which is generally down on a coordinate grid. So when this question asks to go 3 yards east, what it means is starting at the house, go 1, 2, 3 yards east, go to the right 3. And then when it says go 6 yards north, then you go 1, 2, 3, 4, 5, 6. So the answer to the question, which tree would you end up at, is C. You end up at tree C. Does that make sense? Number 4 says, which tree is furthest east? Tree F or tree E? Well, east, again, remember, is to the right? It's over here to the right. So furthest east, let's see, we have F over here, we have E. Which one is furthest to the east or right? Well, if we're going that way, tree E is furthest to the right. Do you see how we're using a coordinate grid to help us not just with distance, but also figure out directionality? Interesting, huh? Let's try one more question. Question 5. Paul wanted to plant a new tree, but wanted to make sure it was at least 2 yards from a pre-existing tree. Should he plant a tree 6 yards east and 9 yards north of his house? So is this location of 6 yards east and 9 yards north at least 2 yards from any other tree? Let's find out. If we go 1, 2, 3, 4, 6 yards to the east, right? We went to the right. And then 9, that's right here. So the answer is going to be no. This location right here is not at least 2 yards from the nearest tree. The nearest tree is A, and that's 1 yard away, one side of 1 square away. So the answer here is no. All right, so as you can see, as long as we are going from one point to another and not backtracking or circumventing something and going around in weird ways, we're always going to come up with the same distance between 2 points. So one more example. Let's say we want to know how far it was from our house to tree C. Well, we could go, let me back up here. I'm not using my laser pointer. There we go. Let's see. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 yards. But if we went a different route, 1, 2, 3, 4, 5, 6, 7, 8, 9 yards. How about 1, 2, 3, 4, 5, 6, 7, 8, 9 yards? How about 1, 2, 3, 4, 5, 6, 7, 8, 9 yards? No matter what route we take, we'll always end up with the same distance between 2 points on a coordinate grid. Today's learning target was, I can measure distance on a coordinate grid. Let's get to work answering some questions about this, and let me know if you need help.